Okay, and then here we are on this Tuesday, and Mr. Samuelis is gone. You're gone, Mr. Samuelis. Okay, that was the one I did in the other hour. Okay, so in the calendar, do understand this. I do have a worksheets, but then there also I want you to go back and do these four questions, and all they are, I think, are just some other. I think they're half life questions. So on your formula sheet, let's go right to that note sheet and get your formula down for half life. Wait, that's all done. What am I doing? Okay, hold on a second. Hold on a second. Ah, no. Okay, I got to get rid of all this stuff. All right, let's see. Okay, good, good, good. All right, write this down for on the back of your formula sheet. This is how a half life question is laid out, I guess. This is the formula for it. So you have your original amount. Sometimes I put population over time equals an initial population times and then all this other stuff. Whatever you want. I just have old amount equals new amount. I'm sorry, new amount equals old amount. My bad, dogs. Times it's half life, so half. You lose a half, so that's what you're half of what you had before. But then the big key is t divided by the amount of time it takes for that half life to occur. So throw that on the back of your formula sheet, and then you'll be able to flip and deal with it. But let's go back to what is this all about? Sorry, I thought I had these blanked out. I thought I got myself ready for two sets of notes. Okay, it's these formulas again. And then I guess I took these from those pages right there. So I want you to understand the difference now, what tomorrow was going to be about and what it is still going to be about. It's actually using a logarithm to find a missing exponent. So John invests $2,300 into an account with a 9% interest rate compounded quarterly. How many times is that in a year, everybody? 3, 2, 1, go. 4. So this tells me what formula I'm dealing with right away. This is your job. Oh, it's this one. I forget, was it called amount? A? Is that what I used? Equals P times 1 plus, it's the one with the K's in it. KT. Okay, how long will it take for it to turn into 4150? Okay. So, what is A? What number is it in this thing? This is part of the problem. Got to figure this out. 4150. And then what's P? That makes that easy. 23 hundo. And then 1 plus, what's R? 0.09. And then what's K? 4. And then here's the rub. It's that. I have to find an exponent. I got to find a T. Okay? So leave that up there for a second. This is the difference. Today's homework, you're just going to plug and chug it, just evaluate. But I just wanted you to use the right formula and know where the parts are. And then tomorrow, you can solve a question like this by knowing what to access. And then, quite honestly, it's a PEMDAS scenario. Do I distribute this 2,300? No, that's a PEMDAS violation. You should be arrested. All right. What should I do with the 2,300? Divide it. Okay, then what? Okay, hold on. Okay, 2,300. Got to divide it. And then I'm not even gonna worry about reducing that. Maybe I could hack off the zeros, but no, I'm just gonna leave. Yeah, maybe I will hack off the zeros, just to write less. It's the only reason I would do that. And then I guess I have to go to my calculator. And I did calculate this before, but I'm just going to do it. 0.09 divided by 4. That's tacked on to 1. Okay, it's 1.0225. It would be smart to write a few things here. Okay, how many positions do I have? 1, 2, 3. This is what you want to get down to, an exponential that has these 3 positions, because now what am I going to change it to? Log. And if you can't do this, you get ready for your F triple plus on Friday. Well, 2 of the negatives cancel, and then you get F minus. All right. So log base what? 1.0225. We'll have people that don't know where these positions are. And I swear to dog, it's going to happen. Of what? What goes next? 415 over 230. I'm not even going to, I don't care. I'm going to the calculator for this. And then equals what? 14. Then what are you ultimately going to do at the end? Divide by 4. But wait a minute. How do I do this? Let me hold off on the dividing by 4. I should cover this. How do I do when I have not a base of 10? You do the change of base over log of 1.0225. Then you divide by 4. Okay, so I'll do that on the calculator. I really want a mouse here. Okay, 415 over 230, so log that. I'm just going to do that first. 415 divided by, watch what I do. Divided by 230. I don't even close that parenthesis because I'm just going to do the top log and get that decimal. Divided by log 1.0225. So I don't have to go crazy about the, closing parentheses correctly. Then divide by 4. So I could do this all on my calculator. Then I could take that answer and divide by 4, all of it, after I'm done getting this big decimal. And then t equals, I think it was 6.631. And then what is that? That's in years. Okay, because I was finding time, and that's what that means. Cold back there with that hoodie on? Oh, I love this one. I love it. Determine how much time is required for an investment to double in value if the interest is earned at a rate of 5.75%. This bamboozled so many students last year. They didn't know what to do because they don't listen, they don't do their homework, they don't pay attention, they do all those things that I was talking about at the beginning. So how much did I invest? I don't know. Pick a number. What do you want to invest? 500 is the first thing I heard. So if it doubles, what does it become? 1,000. That's number one. Just make up something. And then I swear to dog, someone's like, where'd you get a 500 from? Carl. Hey, Carl, you made the video. Yeah, I know. That's why I said in a good way. Carl should have been arrested on Friday, though, but that's okay. E. Okay, now 5.75%. What do I write for that? 0.05. Okay, so again, someone's going to ask, where did you get the it doesn't matter. You know what's going to happen? What's the next thing everyone has to do? Say it. Divide, and then what are you going to get over here no matter what money amount you chose? You're going to get a 2. But this is going to bamboozle so many people on the test because they just can't figure this stuff out. All right? And I hope you can. I know it is a problem. They didn't tell me how much I invested. Invest $1. If it doubles, what does it become? $2. Then 2 divided by 1 is 2. $1 million becomes 2 million. Divide, you get 2. All right. How many positions do you have? 3. This is easy. What's log base E? ln. ln of 2 equals 0.0575 t, and then you divide. I absolutely, positively love logarithms because they're actually really easy. They really, really, really are. And I do like easy stuff, but I also like talking about money. When I come back on Wednesday, we're going to talk who wants to be a millionaire. It's okay. Who wants to be a millionaire? Raise your hand. I'm going to show you how on Friday, on the Wednesday. And then you won't be a millionaire by Friday unless you already are. It takes time and commitment, but it's guaranteed. As long as the stock market doesn't go cattywampus forever in your whole lifetime, which has never happened. Okay, what rate needed? Oh, wow. This is a cave person wrote this. What rate need for investment to triple in 12 years? Compound monthly. Got it. Okay, triple. What can I put right away on this side of the equation? 3, because I invested $1. And then that's the way you could look at it. Got it? Okay. And then 1 plus um, our what rate need. Oh, what rate need R is there, right? All right. And then in compounded monthly, what goes down here? 12. And then raised to the 12. And what mean investor 12 years. There's so many 12s. I'm getting confused. Oh no. Is the exponent unknown? Anything in the exponent unknown? Yes or no? 3, 2, 1, go. No. So guess what you don't need? It starts with an L and ends with logarithm. You don't need a logarithm for this one. So I get 3 equals 1 plus r over 12 raised to the 1/44th power. How do I free this r? What could I raise this side to so that power goes away? 1 over 1/44th power. Holy crow. 1 over 1/44th power. That's why I love this one. It doesn't always have to be a logarithm. That is how we solve this. That is synonymous with the 1/44th roots of both sides. We're raising it to the 1/44th roots. Not raising it. We're taking the 1/44th roots of 3. All right. And then guess what happens? 3 to the 1 over 1/44th power equals a free 1 plus r over 12. And then what should I do next? Subtract 1. I'm going to get this ready for the calculator. And then what? Multiply by 12. So on the worksheet, I have a bunch of these times 12. So I'm going to do that on my calculator. I'm going to just take it in steps here. 3 carrots, delicious. No, not I hit divide. 3 caret, 1 divided by, I know what I'm doing here. So 1 divided by 1/44th power. Press enter. Crazy decimal, minus 1. There's that decimal times 12. Enter. 0.0919. Now, what was I thought I got rid of myself. Oh, that was last video? You're gone again, Mr. Samulus. 0.0919. R is 0.0919 or 9.2%. Okay. Bell's getting close to ringing. You guys can go ahead and talk quietly. I swear to dog, if anyone stands up to line up, you're gone. All right. So no one's lining up anymore. Not happening. All right. And here's a half-life. Here's a half-life of this one. This is the last example. Then maybe I'll show some graphs, like what, graphing every day, and one more review of that if you wanted to look at it. An archaeological dig. A human femur is found. That's horrifying. The femur should have 12 grams of carbon 14, but this femur amount has decayed to 4 grams. For anyone listening, in the half-life of carbon 14, it's 5,730 years. How old is this bone then? Is it less than 5,730 years or more than? 3, 2, 1, go. More than. Why? What's half of 12 grams? 6. 6. And it's down to 4 grams, so more than one half-life cycle has happened. Does that make sense? Anywho, this is what's going to happen. I love the fonts that I have here. Oh, somebody's moving. I guess that's legal. He moved farther away from the door. Okay, so my new amount is 4. My old original amount was 12. In half-life problems, the new amount's less than the old. You're decaying. So one mistake people made is they switched that. Half-life means half, and then T over the half-life time is 5,730 years. And since it's in years, this is all constructed in years. Now, looking up here, everyone look, just to, because this is really easy. This is what I pulled out of the book for tomorrow. I got some half-life questions again, just so you can use it without a graphing calculator. You can do it with logs. But do I take 12 times a half? Yes or no? No, that's a PEMDAS violation. What do we do about the 12 then? Divide. So number one, that is not my problem. If you're multiplying 12 times 1/2, that is a aberration towards PEMDAS. And then how many positions do I have? 1, 2, say it. 3. What do I do next then? Change it to a what? Log. Log base half of 1/3. The whole point of it equals t over 5730. What would be the last thing you have to do? Multiply both sides by 5730. So I would do log, good, log 1/3, 1 divided by 3. I just press enter on that. Divided by log 1 divided by 2. Enter. And then multiply that by, and that's what that 1.5 means. It's gone through 1.58 cycles of half-life. That's nobody's listening. Oh, 9,081.83 years. Okay, and that's it for like what tomorrow's that stuff is. But then, of course, I threw on the worksheet some more graphing. So, hey, where's that asymptote located? At x equals what? -1. Did someone say that? You say -1? No? Oh, no. Not -3, because look at what happens when I plug in -1. Doesn't that get 0 on the inside, right? Yeah. And then look at what I fancily plugged in. Whoa, why -2/3? What's -2/3 times 3? -2/3 times 3 is -2. Sorry. What's -2 plus 3? 1. 5 to what power equals 1? 0. 0 plus 3 is 3. So that's that other point, but this is through logarithms have vertical asymptotes. And they're through vertical asymptotes what makes this 0 on the inside. Okay, then this one real quick, and I'm not going to really spend a lot of time on this, but input, say it. Very first input is this one because of the 0 of this power. -1 plus 1, 0. 2 to the 0 is 1. 1 times -2 is -2. -2 minus 2 is -4. All right, we should know that there's a horizontal asymptote at y equals -2. All right off the bat. And then this 2 is just a multiplier with this negative out here, which flips it over the x-axis. So I'm going to continue by plugging in points. 0. 0 plus 1 is 1. 2 to the first is 2. 2 times -2 is -4. Minus 0, -6. And then -1, -4. And then I could even plug in -2 because -2 plus 1 is -1. 2 to the negative first is a half. Half of -2 is -1. -1 minus 2 is -3. So it just pushes it away from that asymptote a little bit, but it's not really a big deal. So anyway, exponents have horizontal asymptotes. Logarithms have vertical asymptotes. Logarithm, I at least want 1 point, sometimes 2 if the base is nice. Exponents, I want 3. I don't know why I'm showing my hands up here. My face is gone. Oh, it's been a pleasure.